warm welcome. My name is Manpreet Singh. I'm the Director of AI Ops and Software Engineering with Salesforce. I've been working with this organization for more than 8 years now. This is the 9th year. And in the industry, I've had overall 20 years of experience. And I'll just share some glimpse of what I have been doing during this time and working on different initiatives. So moving to the first slide, which talks about, gives you a glimpse of what I have been working on and how we have been using this software in production in the various organizations that I've been working along this 20 years. So on the left-hand side, you see my Scholar page where all my patents and books and the articles, papers, and everything is published. Really proud of the recent accomplishments around artificial intelligence work that we have been doing at Salesforce, my team and myself. And then at the same time, I've been always a very curious student and always wanted to take things from lab into production. Very focused on that, taking a very pragmatic approach on seeing how artificial intelligence in the form it was a few years back and the way it is today, we wanted to use it for the customers, for our society, and see how we can bring that benefit to everyone around us. So I did 3 books and it was a great experience. Writing content is always a very challenging task, and I had my partners in this and did a wonderful job, a lot of great feedback. I'm writing my 4th one now, which is on AI Ops, hoping to publish it sometime this year. And at the same time, you can follow me on the Twitter. I'm pretty active in terms of reading the content and following some of the key people. I'm also active on the GitHub. I don't go by the name, but that's how I usually look at. You start with the bad logic and then you improve over it. So this is the profile, and any of you would want to contact outside the context of this talk, please feel free to reach out to me. Moving on to the next slide. All right. So what is the agenda? I just want to make sure, exactly don't have the purview into the variety of audience that I'm adhering to, but I think roughly, as I understand, Ram, me, and as we were discussing, it'll be good for people who are already into this field. It's great for people who are already productionizing some of these services, and it is definitely one of my areas where I want to inspire the new people who are looking to join this field. And I think BCS gives that great opportunity as it was described in the video. So what is the agenda today? Agenda is just describing AI perspective from my side. And it's a very basic perspective. A lot of you already know about these definitions, but I would want to give my 2 cents there. And then talk about Salesforce AI, because we have been on topping the charts in many of these recent models that have been working in the natural language processing and in the coding field for various areas. So, and then from there, I want to move on to talking about the area that I'm actively right now working on from past 4 years, which is called AI Ops. And I will tell you about the scale that we deal with. I will tell you about the challenges we deal with and how we go about it. And then talk a little bit about software generation and optimization, what we have been doing in this field. And finally, just some experience sharing with you in terms of AI leadership that needs to exist in the companies and outside to make these things really ethical and less biased in the way they are being talked about. Moving on to the next slide. So what is AI? I think in my purview, it started back in the 1943, and the journey has gone through so many cycles. We hear Yoshua Bengio, Jeffrey Hinton, Andrew Ng, so many key people here in UK who have been doing the research in this field, and it has gone, in my purview, from probabilistic to the from I would say deterministic to probabilistic, and then now the natural language or the transformer world as we look at it. And we have come to a time where as it says, artist files a class action lawsuit against the Stability AI and some of the mid-journey organizations and stuff like that. So it's amazing to see how something so mathematical and something so specific to only few people in the field has now become a public knowledge, has become extremely important for businesses to adopt, for educational institutes to adopt, for governments to adopt, and look at various dimensions that I will be talking in the next few slides. And definitely some of the remarkable achievements which a lot of us use in different contexts: speech to text, collaborative filtering. We all use Netflix. We all, maybe we don't all use Tesla, but a lot of us do. And then Siri is one of these examples. Sentiment analysis has been a study, subject of study from a long, long time. Detection, drug and vaccine discovery has been a very active field, and so on. And music lately, if you've played with the latest music LLM, we can talk about it. And it's great to see some of these remarkable AI achievements and how it has been shaping up the next stage of work that we are doing. Sorry. Okay. So, but we need to keep in mind one thing, where there has been a lot of discussions, there have been a lot of blogs, articles, videos, interviews about AI is going to replace us all, and things like that. Again, I'm a professional who's leading this for an organization, and my perspective, I really love this quote, which says AI will not replace you or us. A person using AI will definitely have a larger effect on what we are doing, no matter what vertical you're working on, whether it is manufacturing or CRM, or it could be any kind of industries, even medical industry or airlines industry, and so on. It's only going to drastically move forward. And this is something that we all need to ensure that we inherit and prepare ourselves for the next generation of work that is going to happen in the next 15 to 20 years in this field. And it's going to go very, very fast. I'll talk about the speed in this area. And then, as I said, things are going very fast. If you see on the left-hand side, you will see that the time to reach 1 million users, there was a point in time when it used to take 3.5 years for something like Netflix to reach that kind of user base, and then Kickstarter, Airbnb, and so on. But you look at the bottom one, the Chat GPT, it took 5 days for OpenAI to reach that kind of user base. And we can just, it's exponential. It's very hard to keep up with the amount of, the number of models that are coming in, the number of subject experts, the usage, the pressure in the industry that is piling up is immense. And we all need to cope up with it. We all need to learn, but also ensure that we are building all these applications and products and services with a lot of trust into it. I will talk about trust, what that means for us and what it means for the society around us. And then mid-journey, you can see how the images have improved over a period of time. With version 5, it is fantastic. The next is you bunch all these frames and then you can actually create a beautiful video. So I think we are getting there. As I said, 10, 15 years, we will be there. And then, of course, global search interest, what is AI and how it clearly shows that it was moving very slowly, and in 2023 things have just drastically picked up, looking at how ChatGPT has come into all our lives, no matter whether you're entertainment industry or educational field or any other area of work. All right, now starting with, so that was my small definition of AI and giving you a perspective of what the background is. But definitely, there's no right and wrong definition. It's how you understand and perceive it and use it for the right cause. But I just want to make sure I make the forward-looking statement. And as I said, Ram understands this better because he is aware of the CRM part of the world. This statement is basically that do not make any decisions on buying any of the products based on the talk that I'm giving, because I will be talking about some of the Salesforce AI initiatives and areas that we are working on. Moving on to the first one. So I want to give you what I'm part of, what we do today as a business, and why, and what is the reach that we have. Not many of you may have been aware of this kind of work or this industry or these initiatives. But if you have, then probably you'll enjoy listening to what kind of effect we are creating. So Salesforce is the #1 artificial intelligence CRM today in the world, with the biggest market share. And we have got something called Customer 360. So we've got these suite of products that are part of the CRM family. A lot of these you may have used, like Slack. You may have used Tableau. You may have used MuleSoft. You may have used NetZero. We have industry-specific solutions. We have Service Cloud. We have Success Cloud, Experience Cloud, Commerce Cloud. And all these clouds are nothing but the business units where the softwares are built specifically for those business units and used by many, many customers. I would say millions of customers around the planet, right? And Salesforce Customer 360 and how the innovation has gone in this particular field. It's very important because these companies are the leading edge companies in some of the research areas that all of us are today keen. And I'm ensuring that all of you are aware on what kind of contributions we have been doing over a period of time. So it started with 1999, where we were a simple cloud. We changed the industry. We were the innovative company which brought cloud computing software or enterprise running at a scale which was never seen ever before. Everything running in your browser at this scale was impossible. So Salesforce made that happen. And then from then on, it has been a journey. Right in the middle, you see Einstein, which is our product, which is our AI product that we built. And it was doing a lot of deterministic and probabilistic modelings, and products and features were available. A lot of our customers used them actively. And then slowly, on the way, as I said, Tableau, Slack, and many other things happen. And then finally, we reach a point where today in couple of few, in 2021, 22, and 23, actively, we have already been working on some of these large language models, and our research has been published, which is been a groundbreaking research for many, many companies that have been using it. Now, at the same time, we are all aware generative AI is changing everything for sure, right? As I said, it started with cloud, mobile, 16 years to 100 million. Social has been a great journey. Generative AI, a matter of a few days to few months. It has been such a, I'm sure you use it in different contexts, but if you look at how it has moved and how we have to keep up with the pace with which this technology is moving, a lot of factors will play in, and I'm going to talk about those factors, why I'm specifically mentioning those. But before we go there, I want to give you a snapshot of what Salesforce has been pioneering in. So Salesforce has been pioneering AI for CRM since 2014. We founded our research group back in 2014, and then from there we had Relate IQ, we had Prediction IO and MetaMind, which was a Stanford startup. Richard Socher was our chief scientist. And that was acquired and that was converged into the CRM product. And we provided these natural language and vision APIs for all our customers to use it. And that did beautiful. And the predictions that you see right there, 1 trillion plus predictions a week, which is crazy. That amount of scale is amazing. When you think about how we write notebooks and we do something locally, how we expand into this world of scale, it's tremendous. And there's so much learning because it's not just artificial intelligence, but it is also the underlying platforms or software engineering that plays a vital role in this whole journey. So from there on, we did vision and language. We did bots in 2018, between 17 and 18. We went into recommendation builders in 2021. Teka NLP paper was a very famous one because that was the first attempt ever in the world where we wanted to build one model for all kind of tasks, which is natural language and vision, and even time series at some point. And then we had Einstein search. We had code generation LLM that got released last year, and it did fantastic. It was topping the charts and has been actively adopted by the community. A lot of open source contributions as well. And then we had Slack GPT, Einstein GPT, now released recently. There's an AI day tomorrow actually in London, where we are also releasing some new features for the customers. And then, of course, one of my most favorite part is Code TF, Code T5 Plus language models, because this is what my AI ops team are using, and we are actively part of developing these and opening it to the world. And these are open source, and these are now, if you see the chart in terms of which are the top models, this is the one of the top models for the coding tasks that we have. And then, of course, we had 210 AI patents and 227 AI research papers published in the premier the research areas. Now, at the same time, number one, AI CRM is powered by Einstein GPT. Einstein is our product. That is the core fundamental. And we do a lot of things in that, which I already mentioned. So let me just, go into a more, the area that all of you, I want to inspire all of you to think in this direction while you're learning AI, while you're using AI, while you are thinking of the job market, or you're thinking about skill set, or you're thinking about how this is going to change the world we are in. We need to take care of these aspects. And I'm really proud because Salesforce has been really, really investing deeply into these areas. And we have got dedicated teams and efforts that are happening in this, because today, any customer that you go, without naming any customer, whether it is airlines or banking, or you use cards, you use banks, you use systems that need to be reliable, where your kids are studying, you need to ensure all of this is running in a safe environment and everything is controlled, nothing is hallucinated. So how do you build AI systems unless and until this is taken care of? So this is what Salesforce provides, these fundamentals, and privacy is the top of it. Hallucinations. We all know ChatGPT is a generative model, does a brilliant job at what it does. But once you control the temperature variable of the GPT transformer, you will be able to control the hallucinations, and it can generate the content that never exists. And it is fine, because it is supposed to behave like that. It is supposed to learn from the knowledge around and then you know build something which doesn't exist, which is totally fine. But for businesses, that is critical. You just can't give wrong information out there. You can't hallucinate. So you need to control those variables. Data control has to be there. It is secure data. You cannot leave your and my customer data or our credentials or our banking data out to these models, or get them trained on it. So we need to be very secure about it. You can't be biased. We know all the information that is sitting out there on the internet, or out there in the books, or out there in the human written literature, is some or the other way biased in the form of the person's environment that they have been growing up or living in. So we need to ensure that the bias is reduced to the greatest level that is possible. So we need to invest a lot in there. And toxicity, we need to ensure there's lesser toxicity there. So these need to be the services. And if you look at, AI is the number one priority for the CEOs around the world today. And we deal with a lot of customers. It is number one priority. And it should inspire you enough to think about using this and learning this technology, but doing it the right way. But 59% of customers don't trust companies with their data. If I tell a certain bank or an organization that I will take your data and I'll build some plugin on ChatGPT, if I'm the customer on the other side whose data is going to be leaked on that, I would never want that. You would want all these principles to be applied on that platform. So let's talk a little bit about what we are building at Salesforce and how this is going to change the story. And this is what the Einstein GPT trust layer is. Very briefly talking about it, we have built these software services. There are specific engineering teams and a lot of research that is going on, that your company data will be pumped into the secure channels. It will be complemented with grounding data, like a lot of knowledge articles or books or things that you have for your business or for your, let's say, personal purpose. It'll be all added as a grounded information. You will do right amount of masking. When you send data over the wire, you want to make sure that some of that data is masked. You don't want to leak that information. And then you pass it through the secure gateway. You don't want to persist it across the gateway. There has to be a gateway which provides you a set of models, ensemble of models, where you can use OpenAI, or you can use Anthropic, or you can use Hugging Face, or you can use Salesforce specific open source models, or whatever those are. So you need to have a gateway through which all this information goes, and you get back a relevant score or a relevant information that is applicable for your business, without worrying about how these large language models are curating the data, or kind of processing your data, making sure there is zero retention. So because this is secure data, and the boundaries are clearly marked. And then toxicity detection. Once you return the output, that has to go to the user. You need to ensure that you're giving some information to your customer. The toxicity and the audit needs to be in place. And that is what this architecture ensures. So while you're building applications, you're building software for all these organizations, or your educational institutes, or any area that you are working in, these are some of the aspects that all of us need to take care of. At the same time, as I said, we have shared trust. So data retained in Salesforce with joint moderation with OpenAI. We have very secure channels so that the customers are in total belief. We have hosted models, as I said, Cohere, Anthropic, AWS. Many other models that are coming from AWS are going to be joining into this gateway. And then you can bring your own model. A lot of us are very curious about learning these and training these and building inferencing engine on top of these. So you can always bring in these models as well, which is called bring your own model concept. And The last part of the Salesforce journey that I want to mention here is the deep investment in Salesforce large language models. And this is something for you to explore when you probably leave out of this call, something for you to really think how we are using these models in production, because a lot of these models are used in production today by us, and they're fine-tuned on for customers, and they work really, really well. So as I said, in 2018, we started with Deca NLP, which is a one model adhering to all kind of artifacts. And then we had ProGen, we had Code T5, which I will talk a little bit about towards the end, how we are using it for coding tasks. And then we had Merlion, is a time series library that Singapore research team and my teams built together, one of the most famous open sources from Salesforce. And we're really proud of it. And it does a fantastic job. I will go deeper into it and talk about it in a few slides. And then code generation, as I said, Blip2, which is a vision model. And then we had, talking about Code TF, which gives you that code transformer library where you have one library that takes care of attaching all different kind of LLMs for your use. And this is something you should definitely read about and give a shot in kind of your area of work or your businesses. And the last, it is a Trailblazer economy. And if you haven't heard, the 1.6 trillion new business revenue by 2026, 9.3 million new Salesforce economy jobs. And we have, if you name some of the bigger organizations, they have got the Center of Excellence for Salesforce in almost all partner and service companies across the world. And we have got 19 million Trailblazers across the planet, very vibrant community around the world. And then the 5 guideline principles or responsible generative AI, which I want to make sure that goes right across to you, is being accurate, ensuring safety, mitigating bias, toxicity, and harmful content, being honest, respect the data provenance, and make clear that content is AI produced when it autonomously delivered. Empowering, that's, I think we don't have to say anything about it. Sustainability, right size models to reduce the carbon footprint. We do that a lot. We do that a lot within Salesforce. We ensure we have tracking of how much carbon footprint are we publishing, and we have a metric that we have to follow every month to ensure we are not crossing certain limits. All right, so that was about Salesforce, and I just wanted to set that context of what AI is, how we use it within our organization, and what all we have done so far in many, many years, starting from 2014 and so on. And now going into something very specific, which is AI Ops, which is artificial intelligence for operations in software engineering. So what does operation mean? First, I need to define that. And operations mean, again, as I said, I'm just taking a shot at it. Let's say, you run businesses ranging from startup to big enterprise scale companies, where you have to manage the backend environments, infrastructure. You have to maintain the services for customers. You have to maintain the frontline engineers. You have to ensure that systems are running 24/7 at the scale that it is required. Because imagine you're watching a video, you don't want it to be dragging around. These days, if internet is slightly slow, it's the kind of anxiety that we have. Or imagine you're making a transaction, banking transaction, and something is going out of proportion. It's slow. It's not happening. It doesn't get committed, and you lose money. And you have to do n number of follow-ups to get your money back. And if you're booking an Uber, or if you're doing in a CRM business where you make a call and the service engineer takes a call, and you go through n number of options, and then you reach a person, and then suddenly there's no clue. That is just not acceptable, right? So these kind of operations need to be automated, and there has to be a consistent effort, I feel, over the next very years. And this is a field where I see a lot of opportunities for people to invest in and build careers out as well. At the same time, software engineering. So software engineering is what I've learned in my career over a period of time, is that not all of us are very passionate about coding. Some of us are. And if we are not, then how do we use the technology for the benefit of our work, right? What we are doing and how we are doing. So it's very important that we have the technology working back for us, technology doing the job for us. And that is where the software engineering part comes in. Then if you look at the this particular image, it says a long time back, we were into this manual operations world. We were operating all of this manually, whether system operations, DevOps, or remediating something, detecting anomalies, or finding out causation into something that has gone wrong. It was all manual. And slowly the AI assistant came into picture, statistical analysis came into picture, and then slowly the fine tuning came in picture, where machine centric AI ops became prominent, and then fully automated AI ops. I wouldn't say we are fully automated AI ops yet. I think it's a journey or a process that we have to use, but more and more AI power is coming in, especially with the generative transformers that have come in, and I'm sure we will be able to reach this state. What is an AI ops life cycle? So AI for operations and software engineering needs to have a life cycle. What are you trying to solve for? So many of us, um, it, I'll just try to explain it in very simple terms. The life cycle starts with observation. So you're observing the environments that you are in, meaning um, if you are if you're running a company, you're always observing customer metrics, you're always observing the time series metrics and logs to ensure that if you see any kind of anomalies, um, you need to make the systems aware. For example, if I'm in the e-commerce business, I need to make sure if the orders have suddenly dropped on my e-commerce site, maybe it's a nighttime, maybe that region is going into, there may be a government policy which is not, the internet service provider is affected, or there is something that is going on which is like a positive or negative anomaly that we need to observe. So we need to have enough data to perform analysis on top of. So we need observability in place. Second is detection. Detection needs to be very powerful. You cannot have rules everywhere where I can say that if something goes, if a latency goes above 2000 milliseconds or 5000 milliseconds, then you alert me. Such kind of alerts have been filling our inboxes forever, and we don't do anything about it. So we need our detection to be very refined. We need to ensure that when our car is breaking down or when our system is breaking down, it gives us prior indications, and detection takes place at the right time, predictive detection, so that we can do things about it, right? And then causation. There's wealth of information out there on your businesses, on your educational institutes, or in the medical repositories, or in the company's databases. How do you use that information to come out to the causes? If there is a system where you need to make important decisions, like we are talking today, it's an important call for me, and if I'm not able to log in, and there's huge amount of triage time that the company is taking, Zoom company is taking to fix it, it becomes really unacceptable. Similarly, if there is a company that is fixing your internet banking and taking long time, it's unacceptable, right? We hardly, the maintenance for these kind of websites and these scale businesses only happen during an off peak hours while we are sleeping. And there's a reason for that, that we don't want to bring down these systems when they are very actively need to be used by the society or community around us. So causation needs to be built in a way that we need to go deeper and ensure that the time to cause needs to be reduced so that you can find out what is the root cause behind it. And then auto remediation, you want to auto remediate, you want to use robotic techniques to fix the hard drive, you want to restart a particular app server, you want to probably clear the cache automatically in case something happens. And there are environments around the world which are very personalized environments where humans do not even have access. Imagine the environment where you have data from let's say, armed forces, or you have data from government agencies where humans do not have access. So then how does the self-healing happens? So we need to have systems that are able to do that in those kind of air-gapped environments. And then optimization. It's again, everything that we do today on internet, whether you're opening a site or you're listening to me, or you're going to be doing a lot of reading, or whatever bookings you're doing or things like that, everything needs to become more efficient, and machines can be really good at it because they learn the best practices. They have an ability to perform pattern detection. They have an ability to recommend how to improve those anti-patterns and then go about it. So that's the optimization bucket. So this is the life cycle, observe, detection, causation, remediation, and optimization. On the right hand side, you see some of the data sources. I talk about time series, I talk about logs, traces, and knowledge articles. We all have this in some form or the other. Most common is knowledge articles over which we want to build something like a chat GPT. And That's a very, very valid case in these days. And fundamentally, AI research and libraries, we have produced a lot of open source in this area, which has done extremely well. I talked about Merlin time series library. I will talk about log AI and about PyRCA and so on, which are causal libraries that we have produced, we have used in production, and we have contributed back to the open source community so that others can use it. Now, again, I will not go into too much detail of it, but just give you a little bit of insight into, each of those dimensions that I was mentioning. So a customer impact begins, and then we look into the detection, which is a mean time to detect is very important. You want to reduce that mean time to detect by being very proactive, and you want to build models, both statistical and deep learning models on top of your time series data or log data that can figure out anomalies hand so that you can prevent these kind of bigger incidents. And once such an incident occurs and gives you an indication that there is a problem, then you need to reduce the mean time to triage, which is the causation I was talking about, which is nothing but you again build these statistical and deep learning models, which are built on log data, which are built on the metrics counters, and you can use that to reduce the mean time to triage. And similarly comes the mean time to remediation, where the application of AI is slightly less, but it goes cohesively very well with the detect and triage engine, because that after causation, what is the next thing that you would want to do? So auto remediation, auto scaling, and resource management are some of these areas where you want to go into. And diving a little deeper into each of those sections, where we started with observe, we started with detection, causation, remediation, and then optimization. If I give you a little preview of what observability means in this, when debugging, you want your data to be at your fingertips, right? A lot of people are investing into DevOps, a lot of companies who are building ChatGPT or ChatGPT applications. I always have this thing that I tell my teams and folks I work with or I talk to. It's very easy to build services or applications in today's world. It is extremely hard to maintain them and to make them highly available, scalable, and resilient. It's extremely tough. And it is still tough because of the nature of the applications in software engineering and how we do things and how much human contribution do we need in these areas. So what are metrics? Metrics detect when you have a problem. Logs help you understand why you have a problem. Traces help you understand where you have a problem. Profiling data helps you understand why you have a problem. And diagnostic helps you understand why at a various layers. It goes a little deeper into those operating systems and servers and applications that you're building. So all these are different, I would say, dimensions, as you see in AI, what we call as in a single vector. These are the dimensions that you have to play with so that you can take this vector and then see what you can do with it in the AIOps world to automate this whole life cycle. So that is what the observability is. Now, what is a platform? You need to build an observability platform. An observability platform works at huge amount of scale. I mean, you can imagine, I've forgotten the number, but I think if you just look at YouTube or Twitter or some of these systems that we have internally, I can say, petabytes and terabytes of data per hour to per day to per week. It's crazy amount of information that we are storing. So you need to do a lot of thought process in how much you will store, for how long will you store, how much will you process, how much of that is noise, how much you need to clean for engines like AI to ingest and then perform analysis and produce output. So observability platform is extremely important because it gives you that handler into collecting data, processing data, persisting data, querying and visualizing data. And then, as I said in the last slide, time series, log traces, and all these data sets are the base data sets that we operate on. And data can be collected from multiple sources. It can be collected from CCTV. It can be collected from when we go into the hospital and people are performing analysis on top of it. All of that is a time dimension data that can be stored as images or as natural language or as time processing. And that is wealth of data. How do we get insights into that? By correlating similar patients and things like that. And then granularity plays a very vital role, because what you can see at 1 minute, you may not see at 5 minutes. And what you see at 5 minutes, you may not see at 60 minutes. So you need to ensure that you have different granularities of data that you're playing around with that you're training these large models on. Very important. Again, 100 of terabytes to petabytes of data. And then this observability platform forms the foundation to detection and causation. So again, trying to remind you of the wheel that I was talking about. So from observe, now you'll go into detection and then go into the other areas. So this has laid that foundation for you to go into the next area. Just talking about what we have done in observability. We have been working in this field for quite long, and without observability data, there's no AI, right? No matter what. In a way, internet data that is stored on all these S3 buckets, large corpus that all these open sources and even largely where the OpenAI models have been trained are all lying out there in the S3, which needs to be cleaned, which needs to be tokenized, which needs to be played around with. All this is observability data. For our specific business, for AIOps, observability data would mean the things that I just mentioned in the previous slides. Now, if you look at some of the things that we've done, we have released Centrifuge, which is a JVM warm-up engine. You can read about it. I'll not go inside. Perf Chini, which was recently released by my team, continuous low overhead contextual profiling we do there. Cantor, which is a data abstraction and storage discovery and serving system that we built, and we use it internally. And a lot of my interns who came in, Sanika was one of my interns, and she actually, you can click on this link and go into her website, and she describes what she did with my teams while she was interning with us and how excited she was about different areas that we are operating in. Because AIOps not only operates in software engineering world, but it also applies to many other fields that I was mentioning earlier, many other industries, starting from banking to airlines to hospitals and so on. And then going to the, I think somebody's looking to, okay. Going to the next one, we have written a very nice blog for you to just get, kind of understand the scale at which we are operating and why it is such a big focus. Apart from the AI engines or AI models, this plays a vital role in our lives and journey. So how to continuously profile tens and thousands of production servers. You must read this article. This will be shared with you. So please click the link and you can go into the detail of the blog, and it will give you an idea of what are the challenges we faced and how we actually overcame some of those, because we are making this observable data ready for our models to work on. So this was our effort towards that. And then comes the detection. So we finished the observability part, and now you came into detection. And this is where you have timely detection of incidents from million signals with accuracy. How do you do that? And Medline, as I said, is a library that we open sourced, and I encourage all of you to read more about it, to learn from it and understand why we did what we did. And a lot of us, I believe, you'll be like me, who will take one model which is biased and my favorite, and I will apply it to an observed data, and I'll say this is the best one, we'll go. But when you look at data at different granularity and at different layers, you may be looking at a customer level, you may be looking at a server level, you may be looking at data center level. When you do at different granularities, you need different models. So you need models that can come together and perform calibration. And that is what the next slide describes. So we built this framework where different time series are taken at different granularity given to the engine, where it extracts the features, performs anomaly detection, gives the scores. We calibrate all of those scores and then decide whether it is an anomaly. And that has worked beautifully for us. And we have received amazing feedback from the industry around this. So I really encourage you. Again, you can, inherit this library and bring your own model into it. So you should definitely give it a try. Again, in this area of detection, like observability, we did that, how we profile 10,000 servers, tens of thousands of servers. We wrote a journey to million models. So today in production, we are serving more than million models. And how do we do that? Serving one or two models or models which are behind gateway, slightly easier. But when you have to yourself host it and build your own models for your specific business, it's a very, very challenging task. And please read this blog. It'll give you great insights into how we work through AIOps journey and journey to a million models from a single model. And then comes the causation part. I was talking about observability, detection, and now I'm going to the causation. So it is not easy. The graphic actually shows that you're right in the middle of the ocean, and you're trying to see how do I swim, or how do I find out what went wrong with the vehicle I'm on. So it became extremely important for us to invest a lot of energy in this area where we had to use uh, every aspect of machine learning, um, like deep learning, like statistics, and see what we can build that can ingest all this information, like log and tracing and time series and all this information, and then give us the patterns and give us the causes behind the issue that the detection engine was telling us that something is wrong. You need to find out what is wrong. So we built a library called Log AI, again open source. Encourage all of you to look into it, and it does a beautiful work. It has got a nice small UI as well, which you'll be able to play around with. And this is a very nice example of how we take log processing and we partition that and we do feature extraction using these large models, language models, and we do clustering and anomaly detection. And then finally, we go into the causation. And one very important aspect here is that it's very important to go, uh, uh, each data set is different. Each data set can be carved into different kind of vectors. So you need to spend enough time with your data to see what fits what and ensure that quantitative time is spent there. And then you need to also ensure that the experience says that large language models actually do a very amazing job. You don't really need specialized techniques for parsing such data. You apply large language models directly on them and they do beautiful, which is amazing, right? Um, and then last week, we released this new paper and an open source called PyRCA in the causation analysis. You can imagine whenever we're doing causation, you want to always look at things as graph where you evict things and you see from root to edges what is going wrong so that you can follow that and figure out, okay, this is the spot where things are red and is going wrong. So this is a library that will help you. And this is again a machine learning library that you should delve into, and we have built it with a lot of work that went in last many months, and it is in production, very well used and performing at a great level today. So with all that covered, with the cycle covered, the AI ops, fully automated AI ops, we published a paper back in April this year, where we wanted to give a full perspective of how AI ops is working. So again, I encourage, it's impossible to cover everything in 1 hour or 45 minutes. So I'm giving you this paper that you can read, and please connect with us and with me if you want to chat or if you want to, discuss any of these aspects for your work, or if you're passionate in this area. And definitely thanks to all. Silvio is our chief scientist and the research head for Salesforce, and many other research scientists that we have along with us who've been working on this initiative. And some of the last slides, just to go through that, AI for software. So operations, you saw what we are doing, what kind of depth we have gone in, and what are the libraries we have released in that AI ops lifecycle. And then comes the software engineering, which is a very interesting part today. So many times I get this question saying that, do we need to hire developers? Do I need to know development to do this? And the answer is, you can use these models. Actually, they do very, very good job. You really don't need to now take a book and learn those skills, although the opinion can be different. But Code T5 is this model that we built in-house, which has been topping the charts, which does text to code generation, code auto completion, summarization, pattern detection. As you see on the the code that you require, and works in multiple languages. You can fine tune them to your needs and your, the way you want to do it for your work. And in-house, because this is, again, this is the, after the GPTs came out, we all know that most of the models have been built as decoders only and not encoder decoders. But this is one model where we saw great success with encoder decoder architecture, and this does a fantastic job in those areas. And there's a lot of information on the internet. There's an open source, so you can read a wealth of information on the wiki, and it gives you the insight of what different parameterized models we have trained. We have trained 220 million to 770 million and 2 billion to 16 billion. And the latest is Instruct Code T5 Plus, which is a 16 billion and does a brilliant job today. And again, showing you the charts of where we are today in terms of these models. If you see the first Code T5 plus 770 million was back there when we released it last year, last to last year. And then Instruct Code T5 plus 16 billion. Now I think it is second last because Wizard Code is beating it in evaluation by a point or so. And we are now further refining these, but very important aspect, as I said for you, is that these models are being used in production. So, well tried, well written, and well built. And look at the architecture, see how these tokenizers are trained, and you can go deeper into these. Apart from this, we all want scale. We don't want to see latencies. We don't want to see gaps, and companies are working very hard behind the scene to autoscale. So there is a patent that my architect and we did back in the, I think it was 2 years or 3 years back, where we automatically identify and write these size instances. And this was a pretty famous paper, I would say, that you should definitely read, and it'll give you an idea on how we are designing the equation for autoscaling so that it can fulfill the demands over time. All right, thank you. This is all I had today for you. I think I'm on time, but any questions, any discussion, we can make it interactive. Please go ahead.
Thank you very much, Manpreet. Very inspiring talk indeed. I learned a lot from what you explained. Any questions or comments? I have not seen any comments or questions in the chat, but if you have any questions, you can unmute yourself and ask the question. And Manpreet is here to answer. He has shared his contact details, so you can reach out to him on different channels, and he'll be more than happy to help or answer your questions. I do not see any comments as well. Okay, thank you very much, everyone. Oh yeah, there is one. It's also just, yeah. Yes, the presentation will share with the attendees in due course if Manpreet is happy to share. So I'll check with Manpreet later on, and if he's happy, then we'll share that with all of you, or at least we'll publish it on our website, and you can download it from there. Any other comments?
Definitely, I think I want to add thank you everyone for listening in, and I just designed the session in a way I can make it interactive, but let me know, we can always connect offline, and I hope you learned something. And this is a very, very active field and very inspiring field. So I encourage all of you to contribute, but do it in the right way, because all our future generations, our society is going to be using these applications when they're going to run it. So that's the only thing that I would ask for, being careful.
Thank you, Manpreet. I will now take a few minutes on a slightly different track about AI only. Yeah. So number of people meet me, and especially young people, even elderly people, they ask me, where should the students be going for? What are the areas that they should focus on? And the two areas which I talk about is one, data science, and second is AI. But if you ask me the priorities, then AI is the priority. And next question comes to me is why? And I say it's in its infancy. It's still not to the extent that it should be. And I learned this from Manpreet today as well, when he said for next 20 years, 25 years, it's going to grow and grow and grow. Yes, now that confirms that it's still in its infancy. So this is what I say. The second thing I want to share with you on AI front is to help understand the real application, not on the technical side as Manpreet has explained. He has explained very nicely. Okay, and most of us are technical people, but to help this whole concept further, I would suggest that you should all watch a film called Megan. Okay, it's all around AI. It's all around what technologies can go in and what they can perform, both constructively, productively, and destructively. Okay, and then you can make a call for your organization as to how you want to take it, hopefully in more ethical way, hopefully in more productive way, rather than in the destructive way. So these are the two things I wanted to share with you. And London-based branch of the BCS is very active. We organize about 8 to 10 events every year. We have our LinkedIn page as well. So I request all of you to join our LinkedIn group and be active there as well. Share your thoughts. We are here to offer you more and more learning sessions like these, so you can share your subject interest, and we will try and get the speakers for you. And also, we are keen to have more and more people in our branch committee. So if anybody is interested, then reach out to head office and through head office to us, and we will try and get in touch with you and see how we can best take you on board. There are a few comments, and let me see if there is any question. It is DP100 good combination? Yeah.
Go ahead.
Yeah, so this is one question. Is DP100 good combination with AI courses? Well, I do not know what is DP100. I will need to get back to you on this. What are the best certification or courses for AI? Well, again, difficult. The best thing is to get in touch with the universities. Where can you find the mentioned film? Any of the streaming platforms, be it Netflix, be it Amazon Video, you will find the film called Megan, MEGAN, Megan. Okay. So these are the questions, and that's everything. So we'll conclude our session here. Thank you very much. Thanks, Manpreet, and to give him a round of applause, I am going to unmute all, and then we can, or at least you can use these symbols to, yeah. I'm struggling to, yeah, you can clap using the emojis, and that will be a round of applause for him. Thank you very much, all. And I'll stop recording the session here. Thanks.
Thank you so much. Thank you, Ram. Thank you, everyone, for listening in today.
Thank you.
Thank you.
Thanks.